So here we will solve another problem. It is a model question paper problem of VTU. It is given like this. It is a problem on block friction. So the problem is like this. Given weight of block A, that is WA as 80 Newton. This is 80 Newton. And angle of inclination of the plane theta as 40 degrees. Find the smallest and largest value of WB. So weight of the block B, smallest and largest value, for which the system is in equilibrium. Take mu is equal to 0.25 here. So this is the contact point. Here we have to take mu as 0.25. So here of course these two blocks are connected by a string to a pulley. So this pulley, since it is not given anything, we will assume it as smooth pulley. Smooth pulley means there will not be any friction. So whatever tension force exits on this side of the pulley in the string, same tension force will be there on the other side also. That means tension force develops like this, away from the block we have to take. This is tension force on this side and this is the tension force on this side. So both these tension force will be equal. So T is the tension force in the string or the cable, whatever is connecting these two weights. So we have to find out the value of two values of weight of W, that is block B. One is the minimum weight, WB minimum. Another one is WB maximum. So there are two possibilities. So how to decide that whether it is minimum or maximum, I tell you. So suppose this is fixed, WA is fixed, 80 Newton, that you know, he has given that value. Now suppose if this WB is having minimum value or the smallest value, then what happens, this WB starts moving up the plane, because this will move down if this is less. If this is the smaller value, then the tendency of block B is to move up the plane. Suppose if this is a larger value, then the tendency of the block B is to move down the plane. So that is what, because normally the tendency of a block will be is that it will be moving against the gravity only if it has got lesser value in its weight. So that means it is a common thing. If WB is less, then what happens? This B block tries to move like this up the plane. If it is highest, then naturally it tries to move down the plane. So this is the concept here. So I will write here to have or to find WB minimum. The block B tends to move up the plane, because naturally this weight is less, therefore this weight is more. You can assume that it will move like this. Suppose if this weight is more, then naturally it will move like this, so up the plane. So if this is the case, let me write the free body diagram. So here WB is like this. I will write the free body diagram of block B only. So weight of the block is not known here. It is WB minimum. This value is minimum. This is case 1. This is the first case to find the minimum value. So I have taken the direction of motion like this. So naturally friction force acts in the opposite direction. Normal reaction will be like this. So this F is mu times m according to law of friction. So mu is 0.25 as given. Coefficient of friction between at the contact surface, that is between the block and the plane. So 0.25 times n. N is the normal reaction, F is the friction force. Now this is connected by a string. So the tension force I will take like this. Now this is making an angle of theta. So theta is as given 40 degrees. So this is the free body diagram of the block B when it tends to move up the plane when its value is the smallest. Weight of that block is the smallest. Now, since I have taken the direction motion like this, I will take x direction like this, parallel to the plane, y direction perpendicular to the plane. Let me apply the equations of equilibrium. Sigma f 0 I will take the forces acting in the positive direction of x-axis as positive, opposite direction will be negative. So for that, what I have to do is I have resolved this WB to two components. So one component parallel to the plane, another component perpendicular to the plane. So it will be like this. So this is how you have to analyze. So this since this is theta, so this 40 degrees. This is 40 degrees. You can see alternate angles. This is 90 minus 40, 50. This becomes 40. This becomes 50. So that means this is 40 means this becomes 40. When this is 40, this will be WB cos 40, and this will be WB sin 40. You can see that this is the adjacent angle. So this is how you have to resolve. So I have resolved the weight component, weight of the block into x and y components like this. Now we can apply the equilibrium equation. Sigma of x is equal to 0 equation means, so up the plane is positive, down the plane is negative. So T is positive, tension force is positive in this plane. Then this one is negative. So minus WB sin 40 is negative, and this F is also negative. So minus F is equal to 0. So these two are the forces which are acting in the x direction. So now here you can see that there are T value is not known, F value is also not known. So what you can write here is T is equal to one thing here, correct. Since here this is a smooth pulley, what I told you, so whatever tension force is there this side, same tension force will be there this side also. There is no friction here. So in that case, since this is a free hanging weight, so the weight of the block itself is the tension force in this case. Suppose if you consider the free body diagram of this A block, that is the weight, 80 Newton is the weight here. So whatever 80 Newton is weight is acting here, same thing will be there tension here, because it will be in equilibrium, So whatever WA is there, same value of tension force will be there in this case. That means here T is known. So this T is 80. So this is a very important point. In the case of a smooth pulley or frictionless pulley, the tension in the springs on either side of the pulley will be same. So since this is 80 Newton, weight of the block itself is because it is free hanging. So for equilibrium of this block A, this is the condition. So T should be equal to WA. So this T is known here. Only F and WB there are known. So what I can write here, so this T becomes 80 now, 80 Newton. Now I can write this T as 80 minus WB sin 40 minus F is nothing but 0.25 times N is equal to 0. So this is one equation I can get. Otherwise I can write this as WB sin 40 plus 0.25 N. N is the normal reaction, is equal to AB. So this is the first equation. We can get equilibrium equation, we can get in x direction. Similarly, if you write the equilibrium equation in y direction, that is sigma Fy is equal to 0. So by treating the force acting in the positive y direction as positive, the force acting in the positive y direction as positive, and the other direction, opposite direction is negative. Now N is positive here. WB cos 40 is negative here. Only these two we have to take now. There are no other forces in y direction. So that means N minus WB cos 40 is equal to 0, or I can write N is equal to normal reaction is WB cos 40. Now we have two equations and two unknowns. This is second equation. We have to solve WB and N, they are the unknowns. Now what you can do is, here is, you know the relationship between N and WB from the second equation. Substitute that is the first equation. Substituting for N in equation 1. So it becomes now WB sin 40 plus 0.25 into N we can write it as WB cos 40. See, that's all, right? So now N is eliminated now. WB cos 40 is equal to 80. Is equal to 80. Or in other words, WB will be equal to, I can write this as 80 divided by sin 40 plus 0.25 cos 40. Just we have to simplify this. So if you simplify this, you will get the value as, the denominator is now sin 40 plus 0.25 into cos 40. That is the denominator. So reciprocal of that I will take into 80. So 95.89 newtons. So this is the weight of the block B. That is the minimum weight. Please note that this is the smallest value of W. Smallest value of W. Okay. So this is how we have to find out. Now for finding the largest value, so case 2. So we have to reverse the direction of motion of block B now. So to find WB maximum, block B has to move or tends to move down the plane. Because its weight is more, so due to gravity it tries to move down the plane. So in this case, what happens? The free-body diagram, direction of motion will be down the plane now. So other things keeping the same. See here, this is the block B. So weight of the block B is WB now, and this angle as you know is 40 degrees. So similar to this, now the one difference is direction of motion is down the plane. So that the frictional force acts in the opposite direction. So frictional force direction is now like this. That is the change. So once again it is mu times n, mu won't change, 0.25 times n, then it will be acting like this. And here also if you resolve this to two components, it will be like this as usual. So this becomes 40 degree and this becomes 40 degree. Same thing. So this is WB cos 40, this is WB sin 40. Okay. Then here, since direction of motion is like this, let me assume x direction like this, y direction like this. So usual practice is to take the direction of motion itself as x-axis, positive x-axis, and the other direction will be negative. Now here, tension force as usual will be there. Tension force will be acting like this. Once again, tension force is known. It is 80. So this is the free-body diagram for the second case. Once again, we have to start applying the equilibrium equations. So first equation, sigma fx is equal to 0. Now here, this is positive x direction. Therefore, I take this as forces acting in the down the plane as positive, up the plane will be negative. So this is positive. Please note that WB sin 40 is positive, T is negative in this direction, F is also negative. That means WB sin 40 minus F minus T is 80 newtons is equal to 0. This is the equation. So here once again F is mu times n, that is 0.25 times n. So what I can write here is WB sin 40 minus 0.25 times n is equal to 80. So this is the equation 3 I will take. The next number I will take. I should write the second equilibrium equation, sigma Fy is equal to 0. Treating once again this forces acting in this positive direction is positive, other opposite direction negative. So what are the forces here? This WB cos 40 is down, it is in the negative, and n is positive. Only two forces are there. So n minus WB cos 40 is equal to 0. Once again here n becomes WB cos 40. Same thing what we got in the earlier case. first case. Same thing you get here also. This side that has equation 4. Now second substitute as we did in the first case. So substitute for n. Substituting for n in equation 1 and simplifying. What you will get? You will see WB sin 40. WB sin 40 minus 0.25 times WB cos 40, that is n value, is equal to 80. See the difference here. So here we got plus sign, here we got minus sign. Now if you simplify this, you will get the value of WB as WB is equal to 80 divided by sin 40 minus 0.25 into cos 40. Okay, this is the answer. So let me simplify this. Denominator is sin 40 minus 0.25 into cos 40. So reciprocal of that into 8. 177.27. 177.27. You can see that this is the maximum value, that is the figure value, biggest value of the largest value, you can say. So when the block B is heavier, definitely it tries to move down according to due to gravity. So this is the maximum value and this is the minimum value. So you can write this as largest value of WB. Okay, this is an analysis type of problem. So practical problem, because you should be knowing what should be the block. Suppose if at all you want to slide the block down, till what value? What is the limiting value or the maximum value that the block should have? Weight of that block should have. Similarly, if at all you want to roll the block in this direction, what should be the minimum or the smallest value of the weight of the block? So this is how we have to do the problem.